Let's continue our discussion in Geotechnical Engineering under the topic Compressibility of Soil. Now, the last time, we were able to discuss the principles in compressibility of soil and discuss some formulas that we use under that topic. We also solved two sample problems in the previous video, and that's why we have the second video to solve the rest of the sample problems. So in this video, we will solve the sample problem number 3, 4, and 5. Okay, so let's start with number 3. From the given soil profile shown, the ground surface is subjected to a normally distributed load of 80 kilopascal. So here is the normally distributed load of 80 kilopascal. And this 80 kilopascal is our delta P. Now again, what is the delta P? So we can have it, or we can find it here at the primary consolidation. It's the initial effective stress, it's the effective stress increase in the soil. Okay? So we have delta P as the stress that is added into the soil. So letter A, we need to compute for the compression index. B, okay, so compression index, that is the C sub C. Then B, we need to compute the present overburden pressure at the mid-height of the compressible clay layer. So what are we looking for? Letter B, present overburden pressure, and that is P sub O. P sub O being the initial effective stress at mid-height. So take note, it's mid-height of the clay layer. It's also called the overburden effective stress. So we're looking for P sub O. For letter C, compute the total settlement due to primary consolidation. Okay, so we are concentrating under the second here, the primary consolidation. So under primary consolidation, we also have two classification, the normally consolidated and the over-consolidated. Now here is a shortcut to know if we are going to use the formula for normally consolidated or the formula for over-consolidated. Take note that the difference is that for the over-consolidated, it has C sub S, which is the swell index. Whereas, for the normally consolidated, we only have the C sub C, which is the compression index. Also, we are using over-consolidated formula if P sub C is given. P sub C, or the pre-consolidation pressure or stress. Because if P sub C is present, OCR is greater than 1. Whereas, if we are using normally consolidated here, and there is no P sub C, so 0 P sub C divided by P sub O, that is equal to 0, and that is less than 1. Okay? So that's why the presence of PC, okay, or P sub C, the pre-consolidation pressure, determines if we are to use the over-consolidated. Okay? So we are going to compute for the total settlement. So S settlement primary. So S sub P. So S sub P, under S sub P, we are going to use the formula normally consolidated because there is no P sub C. And how do we know if there's P sub C, or do we solve it? Well, if the problem mentions it, then there is P sub C. Okay, for letter A, for number 3, compute the compression index. So what is the formula for the compression index? So we have here C sub C under primary consolidation, and it's under normally consolidated. We have here C sub C, and we have 2. So either we will use the undisturbed clay or the remolded clay. So the problem did not mention if it is remolded. Therefore, we are going to use undisturbed. So it did not mention that the clay there is remolded. That's why we go for undisturbed. So meaning if it wasn't mentioned, then use the undisturbed formula, and it's this first one. Okay? So C sub C for letter A, C sub C using undisturbed clay, 0.009 times the liquid limit. So liquid limit minus 10, and this is for undisturbed clay. Now, where do we get the liquid limit? So liquid limit will be taken from the clay layer. So in our figure, our clay layer has a liquid limit of 42%. So we have here 0.009 times 42 minus 10. So C sub C is now equal to 0.288. So compression index is equal to 0.288. Okay, so let's go to letter B. Compute the present overburden pressure at the mid-height of the compressible clay layer. So P sub O, mid-height of the compressible clay layer. So this is the clay layer. So the mid-height is here, located 2 meters. Okay. So that is 2 meters from the top of the clay layer. So we have it here, P sub O. Okay, so all we need to do is compute for the effective stress. So for letter B, we just need the effective stress at this point P sub O. Okay, so P sub O is equal to, let's start from the above, the clay layer. So we have there 1.5. So 1.5. Now the question here is, do we include delta P? Well, the inclusion of delta P is later in the formula because delta P is here. Okay? So we just need to find the value of P sub O without the delta P. The present overburden pressure is the pressure without delta P. Okay? So P sub O is equal to 1.5 times the gamma 13.6 plus the height of the sand. We need to compute for gamma of the sand. So what gamma are we going to use for the sand here? So since there is a presence of groundwater table, so the gamma here is gamma sat. So gamma sat for the sand is equal to G plus E over 1 plus E gamma W, that is equal to 2.7 plus E 0.52 over 1 plus 0.52 times water 9.81. So gamma sat is now equal to 2.7 plus 0.52 over 1 plus 0.52 times 9.81. That is 20.78 kilonewton per cubic meter. Therefore, our P sub O now is equal to 1.5 times 13.6. It's too low. Plus the sand layer. So we have there 3.2, the saturated sand layer, and the gamma sat of 20.78. Again, we're looking for the effective stress. Therefore, this is minus 9.81 plus the mid-height of the clay layer, 2 meters. 2 meters times gamma sat 19 minus 9.81. So P sub O is now equal to 1.5 times 13.6 plus 3.2 times 20.78 minus 9.81 plus 2 times 19 minus 9.81, and that is equal to 73.884 kilopascal. Okay, so that is P sub O, or the present overburden pressure at mid-height of the compressible clay layer. Next, letter C, compute the total settlement due to primary consolidation. So, due to primary consolidation here only. Okay? So, letter C. So, what's the formula for primary consolidation? Under normally consolidated. So we have here S sub P time equal to H. H here is the thickness of the clay layer over 1 plus E multiplied with CC, or the compression index, log of P sub O plus delta P over P sub O. Okay? So we have here S sub P is equal to H 1 plus E, then C sub C log of P sub O plus delta P over P sub O. This is also what we call the P final. If you add P sub O plus delta P, that is the P final. Okay? And we have the height of the clay layer, that is 4 meters. Let's use millimeters. So 4,000 millimeters over 1 plus the E of the clay layer. So we're going to use the E of the clay layer here, 0.6. And then the compression index, that is 0.288. Logarithm or log of P sub O, that is 73.884 plus delta P, remember delta P, that is 80 kilopascal all over P sub O, 73.884. So S sub P now is equal to 4,000 over 1 plus 0.6 times 0.288 log of 73.884 plus 80 over 73.884 equals 229.42 mm. S sub P. Okay, that's for number 3. Okay, so screenshot first before we proceed to the next question. Right, so let's go to number 4. Two footings rest in a layer of sand 2.7 meters thick. So in this problem, so there is no given figure. So all you need to do is to comprehend or read the problem carefully and comprehend the figure, how the figure is, the layers portrayed. So here two footings. So we have here two footings, footing A and B, resting in a layer of sand 2.7 meter thick. Footing A and B carries a total load of 450 kilonewton and is 1.5 meter square. Footing B carries a total load of 900 kilonewtons. So the footing A has a dimension 1.5 meter square. What's that? Is that the area or a dimension? Remember, 1.5 meter square is different from 1.5 square meter. So which one of these two is the area? This is the area. If you say 1.5 square meter, so that is the area. This one here is the dimension B, or the dimension width of the footing. So 1.5 meter, and then it's indicating that this the shape of the footing is square. Okay. The top view, if you look at the footing on top view, it's a square. It's a 1.5 meter by 1.5 meter square. So that's what the problem meant. Okay. So let's write here 1.5 meter by 1.5 meter. The footing B, there's no mention of the dimension. Okay. So let's continue to read. The bottoms of the two footings are 0.9 meters or 0.9 meter below the ground surface. So I can now start to draw it, and let's move it here. So it says there these two footings here are 0.9 should I say. They are 0.9. They're 0.9 meters below the ground surface. So we have here line. Okay, so there you go. 0.9 meter. Then, the layer of sand is 2.7 meter thick. So the layer of sand is 2.7 meter thick, and the bottoms of the two footings are 0.9 meter below the ground surface. So, meaning, if that is 2.7 meter thick, therefore, okay, so the sand is having this thickness. Alright? So, it's 2.7 meter thick. So this is sand. Then what else can we read from here? Beneath the sand layer is a 1.8 meter thick clay layer. Okay, so 1.8 meters, so that means 2.9. Okay, so here, this one here is a clay layer. So if this is our sand, so this is our clay layer. And the thickness is, says there, 1.8. meter. Okay? The water table is at a depth of 1.8 meter below the ground surface. So there is a water table that is 1.8 meter below the ground surface. So this is 0.9, then another 0.9, then this is our groundwater table. So let's write here GWT or groundwater table. Okay, so understood that there's water there. And that is 1.8 meter below the ground surface, or let's just put here another 0.9. There you go. Moist unit weight and saturated unit weight of sand is 18.5 kilonewton per cubic meter and 20.8 kilonewton per cubic meter respectively. Okay, so we have here gamma moist. So gamma moist of sand is 18.5 kilonewton per cubic meter. Gamma sat of sand is equal to 20.8 kilonewton per cubic meter. Clay layer has saturated unit weight of 18.8 kilonewton per cubic meter. So gamma sat is equal to 18.8 kilonewton per cubic meter. Right? So we have here the sand, we have here the clay. And then void ratio is given, void ratio E is equal to 1.03 and compression index CC of 0.3. Okay, so CC is already given. Okay, so I think we have all what's needed. Right? So these are the details for this problem. Okay, so for letter A, compute the stress increase at the center of the clay layer and assume that the pressure beneath the footing is spread at an angle of 2 vertical to 1 horizontal. Okay, so what we're looking for here is delta P. Delta P. We're looking for delta P for letter A. Next, letter B, determine the size of footing B so that the settlement in the clay layer is the same beneath footings A and B. So let's look for that's small b, the size of the base. Okay. Letter C, determine the settlement beneath footing A. So settlement S, do we have, so we need to choose. So are we going to use the elastic? So remember, we have here the 3 categories. We have the elastic, remember, the elastic settlement, the primary consolidation settlement, and the secondary consolidation settlement. So we need to choose. Are we going to the elastic settlement? Do we have CS, shape and foundation rigidity factor? Do we have I sub P, that is the influence factor? Do we have the mu here, or the Poisson's ratio? Do we have modulus of elasticity? No, there's no mention of them in the problem. Let's go to the third one. The third one, secondary consolidation settlement. Did it mention time? The problem, did it mention time? No. Remember, for the secondary consolidation settlement, we are concerned with time, and there's no mention in the problem. So we will settle for the second one, the primary consolidation settlement. Again, we will choose under primary consolidation settlement, we will choose if it is normally consolidated or if it is over consolidated. So under over consolidated, does it mention P sub C, the pre-consolidation pressure or stress? Do we have P sub C in our problem, pre-consolidation? The answer is none. So, we will settle with normally consolidated and we will use this formula. Okay? So, this is the formula that we're going to use. We will settle for normally consolidated. Right? So, now that we have the direction, let's start to compute. Letter A, compute the stress increase at the center of the clay layer, assuming that the pressure beneath the footing is spread at an angle of 2 vertical to 1 horizontal. The question here is, which footing is letter A talking about? Is it footing A or is it footing B? It did not mention which footing it needs to solve. But if you look at the two footings closely at the initial situation, only footing A has the dimension. So we can only solve here footing A. So meaning, this is not an erroneous problem wherein the examinee forgot to put which of the footing are we going to solve the delta P. Rather, we analyze that it's actually looking for the delta P of the footing with a given dimension. And that is footing A. Okay, so let's go to footing A. So here we go. So this is our footing A, and let's solve for A. Now it says there that the condition here is the pressure beneath the footing is spread at an angle of 2 vertical to 1 horizontal. This is what it means. Okay? So we are concerned with the mid-height of the clay layer. So this is the mid-height. So remember, this is our sand. And this is our clay. This is our water table. Okay? And remember that this is 0.9 meter. Okay? So we are concerned with the mid-height of the clay at this location. And the spread of the pressure for the footing is 2 vertical to 1 horizontal. So we have this kind of spread from the base of the footing. Okay. There we go. So this is your 2 vertical, 1 horizontal. This is 2 vertical, 1 horizontal. It's the slope of the spread. Okay. And then, what do we need to do? What does it mean having this kind of spread? How do we get the delta P? So delta P of footing A, so let's put here footing A, is actually equal to the pressure, the force there on top over the area. Area where? Area here. The mid-height of the clay layer. So if we look it in a 3D mode, so in a 3D mode, there you go. Oops. oops. Okay, so let's just so this is the 1.5 meter by 1.5 meter base of the footing. So if the spread if we follow the spread of the footing at one horizontal to vertical, so it will be a trapezoidal. Okay, so there we go. So hard to control the pen here. So something like that. Okay, so there goes our spread. This is our area at the mid height of the clay layer, and we need to look for this. If this is the small b, this is the big B. Right? So we need the value of B. So our delta P here is B squared. Okay? That is area M. A sub M is equal to B squared. So how do we get the value of B here? So this is our B. Okay, so what we do here is that, okay, let's separate the triangles. So what is the dimension of this one here? In the triangle, we have the x and the x here, and this is 1.5. Therefore, B is equal to 2x plus small b. The small b here is the 1.5. So how do we get the value of 2x? So from the triangle, what's the height of the triangle? This is 0.9. This is 0.9 plus 0.9 plus another 0.9 here. Okay. There, 0.9. So the height of the triangle here is okay, so the height of the triangle is 2.7 meters. So if the height of the triangle is 2.7, therefore our x here is 2.7 divided by 2. Now, what happens here is we have 2x. Therefore, what is 2.7 divided by 2 times 2? So, cancel 2. What's left is 2.7. Therefore, B here becomes 2.7 plus 1.5. Okay? So if you were able to understood that part there, what I did is similar triangle theorem. Looking at this slope. So if we are looking for the value of x over 2.7, let's use another color. So if I'm looking for the value of x here, and the height of the triangle is 2.7, and the slope is versus the horizontal, vertical, therefore x is equal to 2.7 over 2. Now this is the formula of b, right? So what happens here is twice of x, so twice of b, twice of 2.7 over 2 here, cancel the 2, what's left is 2.7. Then what's b? Small b. Small b is the width of the footing, which is 1.5. So we have here 1.5. Therefore, the value of B now here is 2.7 plus 1.5 equals 4.2 meters. So, if that is 4.2 meters, 4.2, therefore, delta P sub A is equal to 450 kilonewton all over 4.2 meter squared, and that is equal to 25.51 kilopascal. So that's the stress increase. So that's the stress increase at the center of the clay layer. Take note, it says there, center of the clay layer. So this is the clay layer, the 1.8, we took the middle. So that's for letter A. Let's go to letter B. What's for letter B? Determine the size of footing B so that the settlement in clay layer is the same beneath footings A and B. So this is important, especially when we are designing our buildings. We need to have even settlement. So having even settlement meaning we have a stable foundation. So we need to compute what dimension should I put for footing B so that the settlement for A is the same as the settlement of B. So how do we do that? So this is footing B. Okay? Now, since we are talking about settlements, so the settlement, again, what we use for footing A is primary consolidation. So SPA. So let's go back here at A. Okay, so SPA should be equal to the settlement of primary settlement for B. Okay. Now the formula for primary consolidation settlement is CC of A. It should be H of the clay layer. So they have the same clay layer, 1 plus E. They have the same E. Remember, they have the same clay layer concerned. Then they have the same CC, log of P sub OA. So let's decide that later on. Delta PA all over P overburdened at A equals H 1 plus E CC log of P sub OB plus delta PB all over P sub OB. So again, as mentioned earlier, these two footings here have the same clay layer. So meaning they have the same void ratio, they have the same CC or compression index. So what we do here is we cancel here the height of the clay layer, cancel here the E, cancel CC. How about P sub O? Do they have different P sub O at the middle of the clay layer? The answer is the same. Okay? Again, how do we define P sub O? P sub O is the effective pressure without the increase of loads. So without these two loads here, that is your P sub O. Since they have the same clay layer, they have the same layer above it, therefore the P sub O of A and B are the same. So we can now cancel P sub O here. Now what's left? What's left is delta P sub A equals delta P sub B. Now, are they different? They are different because they experience different loadings. Loading for footing A is 450 kilonewton. Loading for footing B is 900 kilonewton. So that's why we can expect that the dimension of these two footings will be different. Okay? So what's the value of delta P sub A again? The value of delta P sub A is 25.51. 25.51. Is that the delta P sub B? Well, again, as mentioned earlier, they must have the same settlement. Now, what's the formula again for delta P? That is the force B over the area M, B. Okay. Area middle. Or that is the force at footing B, and then the measurement of base at footing B, and that is squared. Okay, so we will do the same also with what we did in the footing A. So there is a spread here. So spread also here. So this is the middle of the clay layer. So this is B times B. So what is B here? Twice of X, remember? Okay. So this is 1, 2. So this is B. And this is X and X. Twice of X plus B. And what is our X here? So again, that is X over 2.7 equals 1 over 2. So X is equal to 2.7 over 2. So 2.7 over 2 times 2 is 2.7. Therefore, B is equal to 2.7 plus B. Okay? So, we now have here 25.51 equals the force, 900, all over 2.7 plus small b. So, what's now the value of b? So, this is squared. So, 2.7 plus b squared. So that is equal to 900 over 25.51, square root of the answer. Oops. Then minus 2.7. So 3.24 meters. So the dimension for footing B should be 3.24 meters so that they have the same settlement with footing A. Okay, so that we can have a stable foundation. Let's go to letter C. Determine the settlement beneath footing A. So the settlement of A is the same as the settlement of B. But let's take the A. Okay? So again, we are going to use the primary consolidation settlement, and that is equal to H over 1 plus E CC log of PO plus delta P all over P sub O. Now that is equal to H of the clay layer. What's the H? 1.8. So 1,800 millimeters. What's the E of the clay layer? Again, let's go back. E. 1.03 and the CC is 0.3. So 1 plus 1.03 CC is 0.3 log of P sub O. So what is our P sub O? Therefore, we need to solve for P sub O first. We don't have P sub O yet. So P sub O is equal to, so again, P sub O or the overburden pressure of A and B is the same. So how do we compute for P sub O again at the middle of the clay layer? So that is, we have gamma moist, so 18.5 multiplied with 1.8 plus 0.9, so we have here 0.9 obviously, times 20.8 minus 9.81 because we are looking for effective stress. Next, we have half. What's the half of this? That is 0.9. 0.9 times gamma sat 18.8 minus 9.81. Okay, so that's what we're going to do here. So P sub O is 1.8 times 18.5, the gamma moist, plus 0.9, the gamma sat, 20.8 minus 9.81, plus the gamma sat of clay, 0.9, 18.8 minus 9.81. So P sub O is equal to that is 51.282 kilopascal. So we have now our P sub O, 51.282 plus, what's our delta P for A a while ago? So we have 25.51, and that is over 51.282. So S sub P, the settlement at A. Okay, so if we put here settlement at A is the same as the settlement of B. That is equal to 46.65 millimeters. Okay, so that's for problem number 4. So the key factor here is comprehension. So imagine if you have mistaken 1.5, where is that again? Imagine if you have mistaken 1.5 meter square as the area. So although you have the correct procedure for the solution, if you have wrong data at the beginning, then obviously your final answer becomes wrong. Okay, so the key here is comprehension. $46.65. Okay, let's go to the last problem, number 5. A rigid 3-meter square. So we have another 3-meter square footing. Again, what's that? 3-meter square or 3 square meter. So this is the area. This is the dimension. Okay? So we are not talking about the area, we're talking about dimension and the shape of the footing. So rigid 3-meter square footing is constructed on a loose sand layer 7.2 meter thick. The bottom of the footing is 1.2 meters or 1.2 meter, and the water table is, okay, so it says there the bottom of the footing is 1.2 meter. So does it mean it's from the ground surface? Obviously yes, meaning that's how deep you are to dig. So 1.2 meter, that's the bottom of the footing. Although it did not mention the reference point, but it's obvious that it's from the ground surface. So let's put it here, 1.2 meters, 1.2 meter. And the water, so it says here 3 meters square, so let's put here 3 meter by 3 meter. And then the loose sand is 7.2 meters thick. Okay, so water table is at a depth of 5.2 meters below the ground surface. Okay, so there's the water table. Okay, so let's put it here. So groundwater table. And it's 5.2 meters below the ground surface. Therefore, this one here is 4 meters. The footing carries a total load of 710 kilonewton, and its bottom is 1.2 meter below the ground surface. Again, it's mentioned twice. The water table is at a depth of, okay, so this is a typo error. The water table is at a depth of 5.2 meter below the ground surface. It was repeated. Dry unit weight and saturated unit weight of sand is 16 kilonewton per cubic meter. So the dry unit weight of sand, so this is sand, gamma D is 16 kilonewton per cubic meter. And then the gamma sat, okay, so 7.2 meter thick of a sand layer. So there you go. So this is our sand layer. (7.2 meters. So if that is 7.2 meters, this is 2 meters. And that is gamma sat of 18 kilonewton per cubic meter, respectively. And then we have a clay layer here. Oh, okay. So this time I'm the one who forgot to put the thickness of the clay layer. Okay. Clay layer is, so clay layer is 4 meter thick below the sand layer. Okay. So we have our clay layer 4 meters. So this is our sand, then this is our clay. And it's 4 meters. Okay. Clay layer saturated unit weight, gamma sat equals 20 kilonewton per cubic meter. Void ratio is 0.6. So E is equal to 0.6. Liquid limit equals 45%. Okay. Okay, so compute the elastic settlement of the 3-meter footing if the Poisson's ratio is 0.32, modulus of elasticity of soil is 16,000 kilopascal, and influence factor is 0.88. So, what category is this? It's the elastic settlement. So, we're going to concentrate on elastic settlement for letter A. So, S, E. B. Compute the primary consolidation settlement of the clay layer if it is normally consolidated. S, P. Then, normally consolidated. Letter C. Compute the total settlement of the clay layer 5 years after the completion of the primary consolidated settlement. Time for completion of primary settlement is 2 years. Secondary compression index is 0.02. So we have the total settlement of the clay layer. We are going to solve for S total. Okay. So to solve for S total, we need the S elastic, S primary, and settlement for the secondary secondary settlement. Okay. So we need to go to letter A first. Let's compute for the elastic settlement here. Letter A, formula for elastic settlement. So there you go. So that's the formula. So are we going to use this or this one? Depends on whether we use the chip and foundation factor or foundation rigidity factor or the influence factor. In the problem, what we have here is the influence factor. Okay, so let's write here the given elastic settlement of the 3-meter footing. The Poisson's ratio mu is 0.32. Modulus of elasticity of soil is 16,000 kPa. The influence factor IP is 0.88. So what's the formula for SE? So SE is equal to I sub P small q the B of the base. Then we have 1 minus mu squared all over E sub S. Okay, so we have here, so it says here B here is width or diameter of foundation. Now we need to find small q. Small q here is net vertical pressure, and the formula is small q is equal to P over B squared. P being the force. Okay, that's the force. So we need to solve for Q. Q is equal to F over A. So our F here is 710 kilonewton over 3 squared. So we have Q as 78.89 kilopascal. Substitute all values, 0.88, 78.89. This is 3 in millimeters. 3 meters becomes 3,000 millimeters. 1 minus mu over E sub S 16,000. Okay. Oh, so squared. There we go. So our S sub E is equal to so that is 11.68 millimeters. That's for letter A. Let's go to letter B. Compute the primary consolidation settlement of the clay layer if it is normally consolidated. Again, what's the formula for normally consolidated? SP is equal to H, the height of the clay layer, we have that. 1 plus E, we have the void ratio of the clay layer. C sub C, the compression index, we will solve that. Log of P sub O, we will solve that also. Delta P, we will also solve that. And P sub O. Okay, so let's find the value for C sub C. So it's under normally consolidated. So are we going to use for undisturbed or the remolded? There is no mention that the clay is remolded. So we will go for the undisturbed clay. 0.009 times liquid limit minus 10. So we have there 0.009 LL minus 10. So that is equal to 0.009. Liquid limit is 45 minus 10. So CC is equal to 0.315. Let's go to P sub O. P sub O, present overburden pressure, P sub O. So for P sub O here, we have 5.2 multiplied with gamma D plus 2 times gamma sat 18 minus 9.81 plus the mid height of the clay layer, that is 2 meters, times gamma sat minus 9.81. Okay, so that's our P sub O was 5.2 times 16, the dry sand, plus 2 times 18 minus 9.81 saturated sand, plus 2 times the saturated clay, 20 minus 9.81. So P sub O is equal to 119.96 kilopascal. Next, let's solve for delta P. How do we solve for delta P now? So, there is a way here given. Calculation of consolidation settlement under A foundation. So we can also use this. The delta P average is equal to delta P total, delta P at the top, or pressure increase at the top of the layer. The layer that it's talking about is the clay layer. Then we have 4 times the delta P sub M, or 4 times the increase in pressure at the middle of the layer, we have here the delta P sub B, the increase in pressure at the bottom of the clay layer, and all of them divided by 6. Okay, let's apply that for delta P. So we have here delta P. I think let's use here delta P top 4 times delta P middle plus delta P bottom divided by 6. Okay. So how do we get the values of this? Remember the spreading triangle here that we discussed in number 4. Okay. So there we go. This is the extension. This becomes the delta P top of the clay. This is the delta P middle of the clay. And this is the delta P bottom of the clay. Okay, so we need to find the dimension of B for the top, for the bottom, for the middle, and then for the bottom. Okay, so how do we do that? So let's use a different color. That. Okay, so here we have twice of 1/2 of the height. The height here is 4 meters plus 2 meters equals 6. Therefore, 2 times 6 divided by 2, we have 6 plus 3 equals 9 meters. Next, we have here, so this one here, this depth, that is 4 plus 2, that is 6. And then we have 2 there. So that is 8. So that is 8 plus 3, and that is equal to, so 8 plus 3 equals 11 meters. Oops. Then we have the bottom. So from the bottom of the footing, so we have there 4 meters plus 2 plus 4. So 10 plus 3, we have 13. So this is 10 plus 3 equals 13 meters. Therefore, our delta P total is equal to 710 over 9 squared. Delta P middle is 710 over 11 squared, and delta P bottom is equal to 710 over 13 squared. So this is equal to 8. So 8.765 kilopascal. P middle is 5.868 kilopascal. The bottom is 4.201 kilopascal. Therefore, delta P average is equal to 0.765. So let's just put it here. 4 times 5.868 plus 4.201 divided by 6. So delta P average is now equal to 6.073 kilopascal. Now we have all of this for our formula. Let's now substitute all values to our S sub P. So S sub P now is equal to the height of the clay layer, 4,000 millimeters, 1 plus the void ratio, 0.6, the CC that we solved a while ago, 0.315, log of PO, P sub O, 119.96, delta P, 6.073 all over 119.96. So SP, primary consolidation settlement is now equal to so 16.89 millimeters. Right, so that's for letter B. Let's go to letter C. Compute the total settlement of the clay layer 5 years after the completion of the primary consolidation settlement. Time for completion of primary settlement is 2 years. Secondary compression index is 0.02. Okay, so to understand that, let's go to the formulas. So this is the secondary consolidation settlement, S sub S. So we have the C sub A, secondary compression index. Do we have that? Yes, given 0.02. So this is our secondary compression index, C alpha, 0.02. What else? Time 2 and time 1. So which one is time 2, which one is time 1? Time 1 is assigned to the time completion of primary settlement. Again, let's have the order of settlement. The first one is elastic. The next one is the primary. And the last one is the secondary. So there will be settlement due to elastic, settlement due to primary, and then settlement due to secondary. The secondary settlement is the plastic settlement, or the one in connection with time. So T sub 1 is the time of completion for primary settlement. So meaning it needs to complete first these two. Okay? The completion for the primary settlement. Then time, or T sub 2 is the time after completion of primary settlement. So meaning the reference point is after primary consolidation settlement has been completed. Okay. So what does it mean? So which one is T sub 1? Which one is T sub 2? So our T sub 1 is 2 years. Time for completion of primary settlement is 2 years. Therefore, what's left here is 5 years as T sub 2. It says there, 5 years after the completion of primary consolidation settlement. Okay, let's go to letter C. So let's insert an extra sheet. There we go. For letter C. Formula for letter C here is S sub S. H over 1 plus E C alpha log of T sub 2 time 2n over time 1. Okay. Now, we have our given. Let's put our given first. So, C alpha equal to 0.02. T1 is 2 years. T sub 2 is 5 years. Okay. So we have H here, we have E. No. What's the E here? Okay, so E sub P. E sub P here is void ratio at the end of primary settlement. So it's different. Almost. So this should be E sub P. So we need to compute first for E sub P. So E sub P is equal to E sub O minus delta E. So E sub O minus delta E. Okay? So our E sub O here, or the original, or the initial void ratio. So here, E sub O is the initial void ratio, or the void ratio before the vertical load is applied. That means in the problem, the given void ratio here is actually E sub O. So void ratio before the vertical load is applied, 0.6. Okay, so our E sub O is 0.60. What's our delta E? We know this one, E sub O, but how about delta E? So we have also another formula here for delta E, that is C sub C log of P sub O plus delta P over P sub O. So delta E, So delta E is equal to C sub C log of P sub O plus delta P over P sub O. So CC, given our CC a while ago, it's 0.315. We were able to compute that. That's the CC of the clay layer. So log of P sub O, 119.96 plus 6.073. So that's what we compute also a while ago. All over 119.96. So our delta E is equal to 0.0068. So we substitute it to our E sub P, that is equal to 0.6 minus 0.0068. So E sub P is equal to 0.5932. Okay, so we can now solve our S sub S, and that is equal to 4,000 mm, 1 plus 0.5932. Our C alpha is 0.02 log of time 2 is 5 over 2. So in years. So SS now, S sub S is equal to 19.98 millimeters. So therefore, our total settlement is equal to SE plus SP plus SS equals 11.68 plus 16.89 plus 19.98, that is equal to 48.52. mm. So our total settlement is 48.55 mm. So that's the total settlement for a total of 7 years. Okay? So that's for number 5. Screenshot first. Okay, so this is our last problem for this video. Okay, so stay tuned for our next lecture.